Hello guys, how are you doing? Now today's video is going to be short and sweet because today we are talking about a new yet very interesting physical quantity called linear momentum. Now what's special about momentum is that once you understand it, you can easily understand Newton's second law of motion as well. So are you excited? Well, I hope so because you're not going to want to miss a single word of this. So without sparing a second guys, let's begin. So, what is linear momentum? Well, linear momentum is defined for any object or any body of mass m that is traveling at a velocity v. Now, linear momentum is also casually referred as momentum. So, we'll use linear momentum and momentum, these two terms interchangeably throughout the video. Now, linear momentum is nothing but the product of the mass of the body and the velocity at which the body is traveling. So, we can say momentum p is equal to m times v, where p is the symbol for momentum, m is the mass of the body, and v is the velocity at which the body is traveling. So, if a body of mass 5 kilograms travels at a velocity of 10 meters per second, we say that its momentum comes out to be 50 kg meters per second. Similarly, if a body of mass 3 kilograms travels at a velocity of 20 meters per second, we say that its momentum comes out to be 3 times 20 or 60 kg meters per second. It's that simple. Now from these two calculations you can see that the SI unit of momentum is kg meters per second. Now another important point about momentum is that it is a vector quantity, which means it needs both magnitude and direction to completely define it. Now we have already talked about the magnitude of momentum, which is nothing but m times v. But what about its direction? Well, turns out the direction of momentum is same as the direction of the velocity of the object. So here, if I assume the right direction to be positive and the left direction to be negative, then I can say that momentum of the first object of 5 kilogram mass is actually plus 50 kg meters per second because the object is traveling towards the right direction. Similarly, the momentum of the second object of mass 3 kilograms is nothing but minus 60 kg meters per second because the object is traveling towards the left direction. So guys, by now we have understood the mathematical definition of momentum. We learned about its magnitude and we learned about its direction. But the question is, how can we really relate to the concept of momentum? Or in other words, what does the concept of momentum really mean to us? For instance, we can indeed relate to the concepts of mass and velocity individually. We know that if the mass of an object is high, it feels heavy, and if the mass is low, the object feels light. Similarly, if the velocity of an object is high, it appears to move fast, and if the velocity is low, the object appears to move slow. But what does a high value of momentum really mean? Well, turns out the best way to understand it is by studying the impact. Let me explain. Take two balls of identical shapes, but one made out of plastic while the other made out of steel. Now clearly, the two balls have different masses, as the steel ball is heavier than the plastic ball. Now drop both the balls onto a pile of sand from the same height. Dropping from the same height ensures that both the balls would strike or impact the sand with the same velocity. Now once you drop both the balls, you can see that both of them penetrate to a certain depth into the sand. Or in simple words, both the balls make a certain amount of dent in the sand. But once you remove the balls, you can see that the steel ball makes a much deeper dent into the sand as compared to the plastic ball. But why? Both the balls impacted the sand with the same velocity, right? Yes, they did. But the mass of steel ball was higher than the mass of plastic ball, which means that the momentum with which the steel ball impacted the sand was more than the momentum with which the plastic ball impacted the sand. So due to the high momentum, the steel ball created a much deeper dent at impact as compared to the plastic ball. So I hope this activity gives you a good feeling about the concept of momentum itself. An object possessing more momentum would be more damaging at impact as compared to an object possessing less momentum. So guys, tell me, what would hurt you more? A 450-gram football traveling at 4 meters per second or a 600-gram basketball traveling at 3 meters per second? Take some time and think about it. So, did you get it? I'm sure you did. The right answer is that both the football and the basketball would hurt you equally badly because both of them possess the same momentum. The momentum possessed by football can be written as 0.45 kilograms multiplied by 4 meters per second. This comes out to be 1.8 kg meters per second. Similarly, the momentum possessed by the basketball can be written as 0.6 kilograms multiplied by 3 meters per second. Now this comes out to be 1.8 kg meters per second as well. So you can see both the balls possess the same momentum, which means both of them would be equally damaging or equally hurtful at impact. Now before I end this video guys, let me tell you another fascinating fact about momentum. So momentum can be calculated not just for one body, but also for two or more bodies combined together. And when we combine two or more bodies together in our analysis, we call them a system of bodies or a system of particles. To understand this better, consider two blocks of masses 2 kgs and 5 kgs respectively. I am calling the 2 kg block Block A and the 5 kg block Block B. Now imagine that Block A travels towards the right direction at a speed of 4 meters per second, while Block B travels towards the left direction at a speed of 2 meters per second. Now assuming the sign convention to be right side positive and left side negative, I can write the momentum of Block A, PA, as 2 times 4 or plus 8 kg meters per second. Plus sign here indicates the right direction. Similarly, I can write the momentum of Block B, PB, as 5 times minus 2 or minus 10 kg meters per second. Now here, minus sign indicates the left direction. But if someone asks me to calculate the momentum of the system which consists of both Block A and Block B, I can say that momentum of the combined system is nothing but PA plus PB. Now when I say PA plus PB, I have to add them with their respective signs. The value of PA is plus 8 and the value of PB is minus 10. So the combined momentum of the system comes out to be minus 2 kg meters per second or 2 kg meters per second in the left direction. Now we'll take up the concept of system of particles once again when we learn about the principle of conservation of momentum. For now, let's end this video right away. In the next video, we'll talk about Newton's second law of motion and how Newton uses the idea of momentum to define the magnitude of force itself. For now, let's summarize whatever we have learned so far. Linear momentum is a vector quantity. Its magnitude is equal to the product of the mass and velocity of the body, and its direction is same as the direction of velocity of the body. The magnitude of linear momentum gives us an idea about the extent of damage a body can do at impact. Bodies possessing the same momentum would do similar damage at impact. When we consider a group of bodies together, we call them a system of bodies. The momentum for a system can be written as the vector sum of the momentum of individual particles.